Welcome to Evo AI, where we navigate the intriguing evolution of artificial intelligence. I'm your host, Bogdan Iancu, and in this series, we'll explore how artificial intelligence is transforming the way we work, innovate, and grow. From small startups to corporate giants, we'll unravel the mysteries of AI, uncovering insights, strategies, and the real-world impact on our everyday lives. Whether you're in sales, finance, marketing, human resources, or just curious about artificial intelligence, Evo AI has something for you. Welcome to our third episode of Evo AI, titled Large Language Models. So join us today as we look at all major large language models, their capabilities, so you can choose what works best for you or your company. If you like our podcast and want to know more, just please remember to also subscribe to on our website, evoai.ai, and follow and subscribe to our Spotify, YouTube, and Apple channels. So let's get started. So what are large language models, or LLMs? Large language models, like OpenAI's GPT series, are a type of deep learning model specifically designed to process and generate human-like text. They fall under the category of transformers, a model architecture introduced in a paper titled Attention is All You Need by Vashwani et al. In 2017. We've covered at length the transformer model and the encoder-decoder mechanisms in some of our articles published on our website, evoai.ai. So please go there and you'll get to know more. What are the key characteristics of large language models? First of all, size. LLMs have an enormous number of parameters, often tens or hundreds of billions. The large size enables them to store vast amounts of information. The second one is training data. Large language models are trained on vast amounts of text data sourced usually from the internet, libraries, or elsewhere, enabling them to generate relevant and coherent responses in a wide variety of contexts. Capabilities. Well, large language models can answer questions, write essays, generate creative content, translate from one language to the other, and more. However, they generate responses based on patterns in the training data and don't have a true understanding or consciousness. Generality. Unlike some models that are trained for a specific task, large language models can perform a wide range of language tasks without task-specific training data. What about foundation models? And there are a lot of people that conflate one with the other. Well, the term foundation models was firstly introduced by OpenAI to describe models that serve as foundational building blocks for a wide range of applications. These models, due to their vast size and huge training data, have generalized abilities that can be fine-tuned or adapted for specific tasks. So what are the characteristics of foundation models? First of all, broad utility. So what does that mean? Well, these models can be used as starting points for a wide variety of applications, ranging from natural language processing to image recognition and more. Fine-tuning. Although foundational models are trained on vast datasets, they can be adapted to specific tasks or domains through fine-tuning on smaller, task-specific datasets. Societal impact. Because of the broad utility, foundation models have the potential to impact numerous sectors and domains, leading to both positive applications and new challenges. And also ethical considerations. The use and deployment of foundational models bring forth numerous ethical, societal, and technological considerations, including fairness, transparency, and, above all, safety. So in essence, all large language models could be considered as a type of foundation model when they are used as a basis for various downstream tasks. However, the term foundation model isn't limited to just language models. It can also refer to large-scale models in other domains like computer vision or any other field where foundational pre-trained model can serve multiple purposes. Now let's look at the top leading large language models. The first one that we're going to talk about today, it's one that maybe you haven't heard about till today, which is called Falcon LLM, which is created by Technology Innovation Institute, or TII. Falcon LLM outperforms GPT-3 at a fraction of the cost and matches the performance of similarly sized large language models from DeepMind, such as Chinchilla, or Google, which is Palm, and equally Anthropic. It is also more efficient in terms of training computer power, using only 75% of the training computing power of OpenAI GPT-3, 40% of DeepMind's Chinchilla, and 80% of Google's Palm. Falcon LLM is an open source and available for everyone to use. It is being used by researchers and developers around the world for a variety of applications, including natural language processing, machine translation, and text generation. The development of Falcon LLM is a significant achievement for the UAE and the global AI community. It demonstrates UAE's commitment to technological progress and its ability to compete with the world's leading AI research centers. Falcon is a powerful tool that has the potential to revolutionize a wide range of industries. Once again, it's notable for its efficiency, requiring only 75% of the energy needed for GPT-3 and outperforming it in terms of speed. Its unique system filters high-quality information from the internet, ensuring that it learns from the best available data. Falcon's design emphasizes performance and energy conservation, making it an absolutely groundbreaking development in the field of AI. Let's look at another one, which is developed by Meta AI and is called LLaMA, which, like the animal llama, but stands for Large Language Model Meta AI. And it's a family of large language models that were released by Meta AI starting in February 2023. For the first version of LLaMA, 4 model sizes were trained: 7, 13, 33, and 65 billion parameters. LLaMA's developers reported that the 13 billion parameters model's performance on most NLP benchmarks exceeded that of the much larger GPT-3, which has 175 billion parameters, and that the largest model was competitive with some state-of-the-art models such as Palm and Chinchilla. Just a small parenthesis here: natural language processing, which is NLP, is a very fast field of research, and it consists of many tasks like machine translation, question answering, text summarization, image captioning, and sentiment analysis. LLaMA 2 was released in July 2023, so just recently, and it has a large model size of up to 70 billion parameters. It has been trained on a dataset of 2 trillion tokens. LLaMA 2 outperforms other open-source language models on many external benchmarks, including reasoning, coding, proficiency, and knowledge tests. LLaMA is available for free for research and commercial use. With both LLaMA and LLaMA 2, Meta allows everyone to explore and utilize these advanced models. Next one that we're going to talk about is another large language model called Claude. This was developed by Anthropic BBC. So Claude is a large language model developed by Anthropic, and it's an AI, which is an AI safety and research company. Claude is a chatbot equipped with 52 billion parameters. Its second version, Claude 2, was built with a focus on ethical considerations and safety. Claude is still under development, but Anthropic is working to make it more reliable, interpretable, and steerable. The company is also working to ensure that Claude is used for good and not for harm. The team behind Claude prioritizes responsible AI, integrated principles from international guidelines to ensure that Claude operates within defined boundaries. This responsible approach reflects a thoughtful shift in AI development. Claude is currently in beta and is only available to a limited number of users. However, Anthropic plans to make it more widely available in the future. The next large language model that we're going to talk about today is ERNIE. Well, ERNIE is the only Chinese large language model that we know of anyway. ERNIE 3.0 Titan was developed by Baidu, and it's a very impressive large language model with 260 billion parameters. It's designed to translate and analyze text in Chinese and English and uses an online distillation framework to train smaller models simultaneously. ERNIE's unique methodology and extensive data library enables it to excel in various language tasks, marking a significant advancement in multilingual AI. Once again, ERNIE 3.0 Titan is still under development, but it has the potential to be an extremely powerful tool for a wide variety of applications. Let's talk about another large language model, which is one that has extraordinary multilingual capabilities, and it's called Bloom. Bloom stands out really as a multilingual large language model with 176 billion parameters. It's trained to generate text in over 46 languages, really a feat made possible by the newest NVIDIA AI platforms. While its primary strength lies in text generation, Bloom's ability to tackle various language tasks demonstrates its versatility and opens up numerous applications across languages. Let's talk about another model, which is, we mentioned it earlier, which is Chinchilla, which was developed by DeepMind. It was introduced in March 2022 by DeepMind's research team, and Chinchilla represents a new generation of expansive large language models. The name Chinchilla was chosen as this model, it's an evolution from the prior Gopher model family. The primary objective behind the development of these two models was to delve deeper into the scaling dynamics of large language models. This new Chinchilla model boasts performance metrics surpassing those of GPT-3. Insights from the training patterns of preceding models revealed that for every doubling of the model size, there's a need to double the volume of training tokens. And DeepMind has capitalized on this principle while training Chinchilla. Even though it shares cost parallels with Gopher, Chinchilla has more than 70 billion parameters and leverages data volumes that are quadruple in comparison. On the MMLU benchmark, which stands for Measuring Massive Multitask Language Understanding, Chinchilla recorded an impressive 67.5% accuracy, outshining Gopher by more than 7%. However, we should say this, that as of January 2023, Chinchilla remains in its experimental stages and probably going to be like that for a while. Before we talk about the next large language model, we realize that we probably need to understand what a TPU is. And we know what the CPU is. It's a central processing unit. A GPU, it's a graphics processing unit. But what's a TPU? Well, a TPU, or tensor processing unit, it's a type of application-specific integrated circuit, or ASIC, developed by Google specifically for accelerating machine learning tasks. It's optimized for TensorFlow, which is Google's open source machine learning framework, but can be used with other frameworks as well. Let's look a little bit at the TPUs. Well, first of all, they're purposely built for deep learning. Traditional CPUs and GPUs can handle machine learning tasks, but TPUs are specifically designed for the high computational demands of large-scale machine learning applications. They excel at matrix multiplication, because one of the most computationally intensive parts of training deep learning models is matrix multiplications. TPUs are designed to handle these operations at high speeds. And they have, however, reduced precision arithmetic. TPUs use reduced precision arithmetic as compared to the CPUs and GPUs to speed up computations. This means they use fewer bits to represent numbers. For many machines, the machine learning tasks, this reduced precision doesn't significantly affect the model's accuracy, but offers computational advantages. In terms of memory, TPUs have a large amount of high bandwidth memory, which reduces the need for data transfer, which can slow down computations. And the best part of all of this, it integrates with Google Cloud. TPUs are available on Google Cloud, enabling developers and researchers to use them for training and inference without needing to invest in physical hardware. You can actually rent TPUs if you go on Google Cloud, if you want to develop your own LLM. Google has released multiple versions of the TPU, each improving upon the previous in terms of computational capabilities and other features. I think we're now at version 4. It's worth noting that while TPUs are powerful for many machine learning tasks, whether they're the best choice really depends on the specific requirements of the project. For some applications, traditional GPUs or even CPUs might be more appropriate or cost-effective. However, for large-scale machine learning tasks, especially deep learning, TPUs offer significant acceleration and efficiency benefits. Now that we learned what TPUs are, we can talk about Google's PaLM. PaLM, or Pathways Language Model, it's a brainchild of Google AI, boasting a massive 540 billion parameters. This model was developed using a novel approach called Pathways, which allows the efficient model training across multiple TPU v4 pods. In the case of PaLM, it was trained on a staggering 6,144 TPU v4 chips. PaLM size is not its only impressive feature. It also excels in tasks from common sense reasoning to joke explanation, code generation, and translation. Specialized versions like MedPaLM have outperformed previous models in medical question answering. Google's continued innovations with PaLM, including PaLM 2 and Audio PaLM, represent an absolute technical marvel, which is pushing AI's boundaries. Now let's talk about another large language model that most likely a lot of folks have used, or at least its chatbot, which is OpenAI's GPT-3. So GPT-3 is an autoregressive model which was launched initially in June 2020, and it has a staggering, really, 175 billion parameters, and it outshines its predecessor with GPT-2, which had 1.5 billion only. GPT-3 has introduced breakthroughs in zero-shot and few-shot learning capabilities, enabling it to undertake tasks like translation, question answering, as you know, and more. It opened doors for various applications across industries. As of September 2020, Microsoft obtained an exclusive license for GPT-3, but OpenAI still offers access through a public API. GPT-3 is renowned for its robust performance across a wide range of general natural language processing tasks, but it has its limitations in terms of fine control, creativity, and efficiency in certain specific domains. What about GPT-4? Well, GPT-4 is the successor to GPT-3, and it builds upon its predecessor's foundation, and it has 140 billion parameters. Note here that the size is 140 billion parameters compared to 175 billion parameters of GPT-3. While smaller in terms of parameter count, GPT-4 is architected to optimize performance. It takes generative text creation to new heights, offering unprecedented precision, creativity, and more nuanced control over text generation. GPT-4's ability to generate content in multiple languages and subjects sets a new standard in large language models. Its improved training techniques and architecture have allowed it to outperform GPT-3 in several benchmarks, providing more coherent and context-aware responses. Its enhancements in fine-tuning and adaptability make it a significant step forward from GPT-3. The key differences between GPT-4 and GPT-3 lie in their approach to generative capabilities, control over text generation, efficiency, and specific improvements in architecture and training techniques. GPT-4 represents a refined evolution, focusing on enhancing the quality of output and expanding its application range despite having fewer parameters than GPT-3. Let's talk about another large language model, which is Google's BERT, which are two actually, BERT Base and BERT Large. BERT was introduced by Google's AI team in 2018, and BERT stands for Bidirectional Encoder Representations from Transformers, and has become vital in natural language processing experiments. BERT Base, with its 12 encoders and 110 million parameters, is efficient and small and nimble. BERT Large is the largest variant and boasts 24 encoders and 340 million parameters. It's trained on text data from the Toronto Book Corpus and English Wikipedia, and BERT's ability to understand and generate human-like text has really revolutionized NLP. In October 2019, Google has announced that they were using BERT to better understand the context of words in each queries. This was one of the biggest leaps forward in the history of search in terms of improving the understanding of the context around search queries. BERT helps Google Search better understand the nuance and context of words in searches and better match those queries with relevant results. It's particularly useful for understanding the intent of search queries that might have previously been difficult for Google's algorithms to interpret correctly. As of the announcement, BERT was used for English language queries in the US, but Google had plans to roll this out to more languages and locales over time. Next is Microsoft's Turing-NLG. Microsoft's Turing-NLG has 17 billion parameters and is a significant player despite its relatively smaller size. Its ability to generate cohesive tests and perform in multiple applications proves that effective design can achieve excellence, even without an enormous parameter count. Let's wrap up our episode for today. These remarkable language models, Falcon's efficiency, LLaMA's openness, Claude's ethical considerations, ERNIE's teaching capabilities, and Bloom's multilingual talents represent the forefront of AI technology. From the highly innovative Chinchilla to the groundbreaking BERT, the creativity driving AI's advancements is absolutely astonishing. Palm's adaptability and technological marvel, GPT-3's zero-shot learning followed by GPT-4's generative capabilities and Turing-NLG's efficient design showcase the tremendous diversity in today's AI landscape. All of these models are transforming our understanding of language processing and communication, bridging gaps and fostering innovation. The future of AI is here, and it's as exciting, promising, and diverse as these models that we've explored. Well, that's a wrap of today's episode of Evo AI. We've delved into the fascinating world of artificial intelligence, unlocking insights that are changing the face of business today and tomorrow. But the exploration doesn't end here. There's always more to discover. Well, I'm Bogdan Iancu, and this has been Evo AI. Together, we're part of something bigger, much bigger, a movement towards understanding, innovation, and growth. Well, if you enjoyed our journey today, don't forget to subscribe and please join us again as we continue to explore the future of AI in business. Until next time, keep evolving.